In 1855, inside a small workshop in London, a self-taught inventor poured molten iron into an experimental furnace and blew cold air straight through it. His own workers told him the idea was insane, that the air would cool the metal and ruin everything. 10 minutes later, the apparatus erupted. Flames and sparks shot toward the ceiling, molten slag exploded in every direction, and the zinc roof panels above caught fire. Nobody could get close enough to shut the air blast off. The whole thing looked like a volcano had opened up inside the building. When the chaos finally died down and the smoke cleared, sitting at the bottom of that wrecked converter was something nobody had produced at this speed or cost before: steel. The man standing in front of that burning wreckage was Henry Bessemer, and the contraption that nearly killed him would go on to collapse the price of steel from £50 per ton down to 6, feed an empire stretching from American railroads to the Chicago skyline, and physically rebuild the modern world from the ground up. Henry Bessemer was born in 1813 in Hertfordshire, England. His father, Anthony Bessemer, was an inventor who had worked at the Paris Mint, barely escaped the French Revolution, and settled in England running a type foundry. Growing up without formal higher education, young Henry received tools instead of toys, absorbing practical metallurgy in his father's workshop. Moving to London at 17, he began inventing. After designing a forged revenue stamp that the British government adopted without paying him, he learned a lifelong lesson: patent everything before showing anyone. His next invention, a mechanized process to manufacture gold-bronze powder, was kept under tight secrecy. The profits from that business funded every experiment that came after. Then, a war on the other side of Europe pointed him toward the invention that changed everything. In 1853, during the Crimean War, British and French artillery faced severe issues with fragile cast-iron cannons shattering under pressure. Bessemer designed an elongated spiral-grooved shell to improve artillery range and accuracy, but French military testing revealed a major flaw. Standard cast-iron cannons could not handle the force of these heavier projectiles. If the military needed stronger guns, they needed stronger metal. They needed steel. In 1853, steel was a luxury material. It cost around £50 per ton, and converting iron to steel took roughly 10 days in tiny, expensive batches. Bessemer spent 2 years in his workshop seeking a faster method. The prevailing refining process, called puddling, involved manually stirring molten iron in a furnace to remove impurities. Bessemer hypothesized that forcing cold air directly through molten iron might speed up oxidation. When he tried it, the cold air hit the molten iron, and the oxygen reacted exothermically with the carbon and silicon inside. Instead of cooling, the metal's temperature surged. The reaction burned away impurities while generating its own intense heat, turning the process into a self-sustaining chemical reaction. In August 1856, Bessemer announced his breakthrough at the British Association for the Advancement of Science with a paper titled "The Manufacture of Iron Without Fuel." Ironmasters rushed to license the technology, paying hefty upfront fees. However, when they tried to replicate the process at their own works, every single one failed. The resulting metal was brittle, crumbly, and useless. Furious ironmasters demanded refunds, accusing Bessemer of fraud. Bessemer had unwittingly used unusually pure, low-phosphorus iron ore in his early experiments. The ore available across most of Britain and Europe contained high levels of phosphorus, which his converter had no way of removing. Phosphorus contamination ruined the steel's structural integrity. The solution came from Robert Mushet, an obscure, brilliant metallurgist working in the forest of Dean, Mushet recognized that attempting to stop the air blast at exactly the moment carbon reached the right level was unreliable. He proposed a two-step approach: blow all impurities and carbon out completely, then add back a precise quantity of Spiegeleisen, an alloy of iron, manganese, and carbon. The manganese neutralized sulfur and remaining oxides, while carbon restored the metal to precise specifications. This turned a chaotic guessing game into a controllable industrial standard. Bessemer adopted the method, ensuring the commercial viability of his converter. Later, in 1879, Sidney Gilchrist Thomas developed a limestone-based converter lining that absorbed phosphorus, unlocking the process for phosphoric iron ores across continental Europe. Tired of fighting skeptics, Bessemer set up his own manufacturing firm in Sheffield in 1859. Combining low phosphorus iron ore, Mushet's chemistry, and his converter design, Henry Bessemer and Company produced cheap, high-quality steel that undercut traditional manufacturers. By the 1880s, Sheffield alone produced 10,000 tons of Bessemer steel every week. Steel prices plummeted from 50 pounds a ton to less than 7. Across the Atlantic, Scottish immigrant Andrew Carnegie recognized the transformational potential of cheap steel for American expansion. Iron rails on busy train lines wore out in 2 years, whereas steel rails lasted 15 to 20. In 1875, Carnegie installed Bessemer converters at the Edgar Thomson Steel Works in Pennsylvania. By vertically integrating his supply chain, controlling iron mines, coal fields, railroads, and blast furnaces, Carnegie drove American steel prices down from $100 per ton in 1873 to $18 by 1890. The structural impact was immediate. In 1874, the Eads Bridge crossed the Mississippi River using steel arches. In 1883, the Brooklyn Bridge spanned the East River using thousands of miles of steel cable. In 1885, the Chicago Home Insurance Building used an internal steel frame to pioneer the modern skyscraper, proving that cities could grow vertically. Eventually, the Bessemer converter was surpassed by the open hearth furnace, which offered better chemistry control and could recycle scrap metal. Yet the pear-shaped converter remained operational for over a century before the last units were decommissioned in the late 1900s. Sir Henry Bessemer passed away in 1898, having lived to see his invention construct the bridges, skyscrapers, and railway networks of the modern world.